Okay. Hello all. Today we are going to see the topic called dynamic memory allocation. Okay, so what is dynamic memory allocation means? In the last video, we have seen that command line argument. That means how do I get multiple set of input in the runtime for a single variable? Okay, so for that we are going to pass the parameter in the main function itself. We can call it as command line arguments. Here in this video, we are going to allocate the memory at the runtime. Here as a funny example, we are going to have some kind of example here. So here what we are going to do the example means ticket booking system. I am going to take ticket booking system as an example here. Before getting into the example, let me explain the particular what is dynamic memory allocation. That means it enables a C programmer to allocate the memory at the runtime. This is very important topic for before you are getting into the data structures and algorithm subject, you have to expertise in this particular concept, or otherwise you do not know how to allocate and deallocate the memory, because when you are going to study about linked list concept or tree or any kind of data structure algorithm in the future, from using C program, if you are going to implement means you need to thorough this particular dynamic memory allocation concept. So it will be very simple that we have to allocate the memory at the runtime. So I am going to allocate some kind of memory at the runtime. Before I am not going to fix any memory at the compile time. I am going to fix the array of memory at the runtime. So what are all the four different predefined functions are there that are existed in the std library means, first of all, malloc. Okay, so malloc will allocate the memory as per it will going to allocate the memory as a single block. For example, I am going to allocate 16 bytes of memory means as a 16 bytes of memory it will allocate as a single block memory of block of memory, and it will allocate it. And as well as our additional information, malloc obviously it will going to as a initial value, malloc will going to fill it up as garbage value. For example, if I am not giving any data into that memory, some garbage value will be filled up in the malloc. If I am implementing malloc function in my C program, it will allocate it as garbage value. calloc means it will going to allocate a multiple block of memory. Based upon my data type, separate block of memory will be allocated, as well as it will initialize the as 0. Whenever I am going to allocate the memory, my initial value, all the memory initial value will be 0 for calloc. Realloc means it will work with malloc and calloc also. It will going to extend the memory or reallocate my memory. Either it will extend the memory or reallocate the memory. Using the program we will see now. And free is a function which will going to just release the memory after my execution. It is like while you are getting into the movies, you have watched the movies. After 2 hours of movies, okay. So when you are completed watching the movies and we are getting out of the movies, that seat will not be yours. You are releasing your ticket and somebody will going to use that particular seat. Same as like the talk. Whenever we are going to use that memory, we are going to using that memory at the runtime. Afterwards, some processor or some particular application will use that memory. So we should not hold the memory if you are not using it. So only manually we have to free that memory whenever we are completing the process. For that we are using free function. Okay, first thing, I am going to initialize my pointer variable. It is a I for my logic I am implementing. Here I am implementing the pointer variable called ARR. Why I am using my pointer variable means here I stated as memory at a runtime. It will going to allocate the memory whenever the concept of memory is there in the C program. we have to or we should use pointer variable. So here ARR is a pointer variable. So I am going to allocate my set of memory using the pointer variable. Here my pointer variable is ARR, and then initially I am getting some kind of size from the user. Okay, here what is our particular environment is I am going to book the ticket for Bhagavad Kesari. Here recently that particular movie is released by Mr. Hero of Balaya. So I want to book the ticket for Bhagavad Kesari. So I need to book the ticket for that. So for that what I have to do means I need to know how many tickets I need to book. So I am going to get the ticket from that. Okay. So let me first compile this program, then you will understand. So first of all, I am going to book the ticket. I am going to book the 4 ticket. Okay, so I am giving total 4. Totally 4 memory will be allocated. So for ticket number, for C programming purpose, I am entering as integer 1, 2, 3, 4. So my ticket will be allocated 1, 2, 3, 4. Obviously, in our friends circle, somebody wants to, in the last time they want to join with us for the movie. No? So they want to join the last time they want to join for the movie. So they need to have some extra ticket. So what maybe already 4 tickets we have reserved. We are going to reserve another. We need to reserve 3 ticket means I am going to give as 3 and I am going to reserve 5, 6, 7. Automatically my array will be enlarged from 4 to 7. Okay, so this is the way I am going to use my mlock and clock and realloc free function everything in one program. Okay, so this is the execution. Let me go to the program. First of all, I have used the mlock here. Either you can use mlock or clock. But note that one thing, when we are going to want to allocate the memory as a single block, you can use mlock. When you want to use allocate the memory as a multiple block, you can use clock. Okay, here I am using the malloc function here. Okay, so I am going to use the malloc function. So let me explain how this syntax will be. First of all, the first thing is int pointer. It is here they are specifying it as int pointer. Int pointer means my particular memory allocation will be in the integer data type. Second thing, they are stating out size multiplied by size of integer. That means size. For example, I am giving here as 4 as a size. Okay, here 4 will be the integer. Okay, 4 will be my integer. Okay, so mloc of I am giving 4 is my initial size. I am giving star size of an integer. What is the size of an integer currently in C program? 4 bytes. Okay, so my size of an integer will be 4 bytes. So automatically, if you see that, it will going to give 16 bytes. 4 into 4 bytes, 16 bytes. I am allocating 16 bytes here. So the 16 bytes will be held by ARR. This pointer, the 16 bytes of address will be held by the variable called ARR. Okay, so initially here I am using malloc. Okay, here I am using malloc. So first of all, let me as a procedure, I am just verifying whether my particular variable is existed or not, whether my address is mapped or not. If it is not mapped, I am going to print some particular message and I am going to return 1. When it is return 1, obviously we know that it will going to terminate the program, it will come out of the process. Okay, so and then let me going to demonstrate that how the malloc will work, how the clock will work. Okay, next step we are going to see. Here I am going to disabling my for loop. I am not getting any value from the user, but I am just going to print my array. I am going to print my memory as an array. Okay, my pointer variable as an array, I am going to print from 0 to size. Okay, so let us see what will happen. Compile and run I am using, and then for your reference I am going to give only percentage %d here. Okay, it will be easy for you to understand. So 4 I am giving. Okay, by giving 4, number of movie tickets are 00. It is initialized as 00. Actually, we are using the malloc here. Okay, so let me compile it again. Hmm. So it will initially it is allocated actually in the malloc. It has to allocate as garbage value. Now it is allocating me as 0. Okay, if I am going to give CLOC also, CLOC also performing the same operation, but it will allocate as multiple blocks. Memlock will allocate as a single block. Same thing I am executing here. 4. If I give 4 means again it will going to give it as 0000. But what is the difference? CLOC will allocate me with the help of multiple blocks. Multiple blocks means here I am declaring my size as an integer. Okay, integer will carry 4 bytes. Obviously, what will happen means 4 bytes. Single block will be allocated if I am using CLOC, or if I am using MLOC here, totally it will allocate single 16 bytes as one block. Okay, so this is the difference of CLOC and MLOC here, and we are going to get the value from the user using the scanf. Okay, here as a real-time example, I am using the ticket number as a, I am going to store it into my array. Then I am going to print my ticket number. Obviously, our ticket number is not in the numbers. It will going to start with A1, B1, C1. At the sample, I am just defining as A1, A2, A3 like that. Okay, so obviously up to here my MLOC and CLOC will work, or my MLOC either my CLOC based upon my implementation it will work. Okay, both the syntax representations are same, but the syntax will be different. MLOC you have to give it as size multiplied by size of function. CLOC will have to give by size comma size of function. Size of function will return the total memory size of my data type. Okay, so don't forget that CLOC will be the syntax will be different, MLOC size syntax will be different. Okay, next we are you want to allocate the another extra seats. For example, I booked 4 in my example I am already booked 4 ticket means now I want to book extra 3 tickets. So I need some extra memory space now. Okay, now I am having only 4 tickets, but I need extra 3 tickets. So I am going to have new size. I am going to get the particular updated seats. How many seats actually I required? New seats I actually required. I am going to get the particular total number of updated seats from the user. Now I want to use the same process using realloc. I already told you realloc will be reallocate the whole memory, or it will going to allocate my extend my memory. Here I am going to extending the memory. So I am using the realloc for in which pointer variable I am reallocating ARR. Okay, how much size I am going to reallocating? Okay, based upon the new size. For example, here I am going to allocating, say for an example, I am using the integer pointer. That means I am allocating the variable in the integer data type followed by real log ARR, comma, my new size will be 3, star, my size of an integer will be 4 bytes. So, when it is coming 4 bytes, you see that, so 3 into 4, automatically my particular size, my new size will be updated as 12 bytes. Okay, so imagine that I am already, I am having 16 bytes. After extending the memory, I am going to add extra 12 bytes. So totally, I am getting now 28 bytes. My totally memory, my ARR will going to here, it will going to take care of 28 bytes. I am assuming initially my ARR will is handling 16 bytes. Now it is extra, it is handling 12 bytes. So totally 28 bytes currently it is handling. Now I have extended my memory to 28 bytes, but I need to allocate where I left. For example, already 16 bytes memory, some data is there. I am going to fill up my data for the remaining 12 bytes. So for that, what I have to do means I am going to start with the size from the current pointer where I left last. For example, already I am having 16 bytes mean from the 17th byte I need to start. So I am going to start from the size. I am going to give size plus new size. Why? Because already one updated size will be there as well as previous size will be there. So I need to I need to add two size to fulfill the all my datas in my memory. So I am adding size, new size plus size. Okay, now I am going to get the variable from the value from the user, but which value? From the size to the new size plus size. So what is size actually? What the size will be already we got initially, we completed that process. We get 16 bytes of data from that. But here I am going to start from the 16th byte and I am going to end with the 28th byte. Okay, from the 16, after 16 to 28, I need to complete it because already 16 bytes of data is already allocated. So after 16 bytes, I am going to fulfill the data. So I am going to use it like this and then I am going to print the data. Okay, so let's see. Finally, after the execution, as I already told you, whenever the execution is completed, we need to free the memory. So only other application in our laptop will utilize that 28 bytes. I am going to utilize my 28 bytes only during the execution. After the execution, I want to release the 28 bytes. So I am using free function. So let me execute it. As I told you, first I am going to allocate as an example 4. I am going to book the ticket for 4 persons. So ticket number 1, ticket number 2, ticket number 3, ticket number 4. So all are in integer. So 4 into 4, 16 bytes I am allocated. But A1, A2, A3, A4 tickets are allocated. Now last minutes my friend want to join with me for the particular flip. So what I have to do means for last minute 3 friends are coming. So while the three of my friends are joined in the last minute means I need to book 3 extra tickets. That 3 extra tickets I am going to fix the seat number as 5, 6, 7. You observe this. First, my array of memory size will be A1, A2, A3, A4, 16 bytes. But now it is extended to the 28 bytes. How come I am saying this as 16 bytes? Everything is an integer. So A1, A2, A3, A4. So 4 into 4, 16 bytes. Here A1, A2, A3, A4, A5, A6, A7. 7 into 4, 28 bytes. I am extending my memory without touching my program in the runtime itself using mlock and realock. You can use clock also, you can use mlock also. Here I am using mlock. You observe this. First I am using the mlock here. Okay, now I am compiling it. I am using 4 and I'm using 1, 2, 3, 4 and 3 and 5, 6, 7 as same output. Here you see that 13.62 seconds will be there. Okay, let's check with the execution time of CLR. Okay, so let's see the execution time of CLR here. So if we are getting into the execution time here, compile it. Okay, 4, 1, 2, 3, 4, 3, 1, 5, 6, 7. If you see that it will be 11 seconds. Okay, so you need to, it is not that we have to use CLR for minimum number of time based upon your requirement. Either you want to allocate the memory with the multiple blocks or single block, you have to decide. Okay, so where we have to decide as a single block or multiple block means when you are getting into the data structure topic, you easily understood that where you are going to use CLOC and where we are going to use MLOC. Okay, currently we have to clear the top. We need to clear with the concept of CLOC and MLOC, realoc and free. These four functions in dynamic memory allocations are important, that are all the basics of data structures. Thank you.